ACDH Tool Gallery, Generative Artificial Intelligence and Vibe Coding. Chapter 3. Vibe Coding, the Future of Programming for Everyone. One of the most common questions aspiring IT professionals ask is which programming language is the most important? The answer may surprise. It is not Python, not Java, not C. The most important programming language of the AI age is one you already master, one you have spoken your entire life. It is your natural language. German, English, any language in which you think and communicate. If you understand the words I am speaking right now, you already know the programming language of the future. You may just not have seen it that way yet. And this is exactly what makes this talk particularly relevant for you as humanities scholars. Because formulating precisely in language, expressing connections clearly, and giving understandable instructions, that is precisely your core competence. Why do programming languages exist at all? Imagine you want to bake a cake. You start with an intention, I want a cake. You then translate that intention into instructions, the recipe. And finally, you carry out the instructions and get the result, the cake. With computers, things worked similarly until recently. You had an intention, say, to write a program that performs a specific task. You then had to translate that intention into instructions, but not in your own language, rather in the language of the machine. And that was precisely the problem. You first had to learn a foreign language, the machine's language, before the computer could even understand what you wanted. This intermediate step, the translation from human intention into machine language, was the great hurdle for decades. Let me briefly trace how programming languages have evolved over the decades. At the beginning stood machine languages, cryptic sequences of numbers that only the computer understood. Then, in the 1960s and 70s, came higher-level languages like Fortran for mathematics or COBOL for the business world. Those already looked a little more human, but only a little. Then came structured languages like Pascal and C, which made code better organized. In the 80s and 90s, object-oriented programming arrived with C++. The web brought Java and JavaScript, and finally scripting languages like Python that simplified many things. Each of these generations was a step closer to human thinking, but none of them was truly natural. Nobody speaks in everyday life the way programming code looks. The languages became more human, but they remained foreign languages. And then came the AI era, and with it, a fundamental paradigm shift. Large language models understand natural language. This means we no longer need to translate our intention into a programming language. We can go directly from intention to result. Artificial intelligence handles the translation for us. In the past, you needed 4 years of computer science to learn the machine's language. Today, computers understand our language, whether German, English, Spanish, or Mandarin. This is the real revolution. Not we adapting to the machine, but the machine adapting to us. And the beautiful thing is, this language you do not need to learn. You already speak it. For you as humanities scholars who are accustomed to formulating precisely and arguing with nuance, this is particularly good news. Let me illustrate this development with a vivid image. Imagine a doormat that says welcome, but not in letters, rather in ones and zeros, in binary code. Even a table full of software engineers would need a while to decode that. And that is precisely the point. If the message says welcome, but the recipient first needs a calculator to understand it, then communication has failed. Computers speak language A, binary code, ones and zeros. Humans speak language B, natural language. The history of computing is the history of the layers of abstraction that bridge this gap, from machine code, through assembler, through compiled languages, up to generative artificial intelligence. With each layer, the distance grew smaller. And with generative AI, the gap is finally closed. The computer now understands our language. This opens the door for everyone who brings expertise, even without programming knowledge. If natural language is the new programming language, what does that look like in practice? Here a concept comes into play called vibe coding. The term literally means giving into the vibes, letting yourself be carried by the flow. Concretely, it means you describe to an AI model in natural language what you would like. For example, create a website that showcases my research projects, and the AI generates the corresponding code. You do not need to write this code yourself, nor understand it in detail. You look at the result, tell the AI what you would like to change, and the agent adjusts the code. This works directly in the browser, in special code editors, or even via the command line. Vibe coding makes software development accessible to people who have never written a single line of code. How does vibe coding work concretely? It is a cycle of 4 steps that repeats. First, you formulate a prompt, an instruction in natural language that describes what you want to achieve. Second, the agent generates code suggestions and shows you which files it wants to create or modify. Third, you review the result. Does it work? Does it look the way you imagined? If yes, you accept the suggestion. If not, you reject it. Fourth, you run the code, examine the result, and if needed, formulate a new refined prompt. Then the cycle begins again. This iterative approach, describe, review, adjust, repeat, is the heart of vibe coding. You approach the desired result, step by step, in dialogue with artificial intelligence. What is vibe coding particularly well suited for? Above all, rapid prototyping, turning an idea quickly into something tangible. You can build a demo application, design a user interface, or create small tools that make your everyday work easier. Scripts for recurring tasks can also be generated this way, renaming files, reformatting data, merging tables. For the digital humanities, this is especially interesting. Imagine being able to have a small tool built that processes your research data, generates a visualization from your metadata, or automates a workflow step that previously required hours of manual work. All of this without writing a single line of code yourself. You describe what you need, and the agent builds it for you. As impressive as vibe coding is, there are important limitations one should be aware of. Language models can hallucinate, meaning they sometimes produce results that sound plausible but are simply wrong. The generated code can contain errors or pose security risks, for instance if sensitive data is processed without protection. Additionally, vibe coding skips many proven practices of software development, such as systematic testing, code reviews, and documentation. This does not mean you should not use it, but you should do so with healthy skepticism. And this is precisely where a strength of the humanities lies. Critical evaluation, questioning sources, recognizing inconsistencies, these are skills you already have. Vibe coding does not mean blind trust. It means letting the agent do the work, but judging the result with a watchful eye. How do you best get started? 3 simple ground rules will help you begin with vibe coding. First, formulate clearly and precisely. The more exactly you describe what you want, the better the result. Give the AI context. What is the goal? Who is the result for? What constraints are there? This is no different from a good assignment for a seminar paper. Second, work step by step. Do not demand everything at once. Let the AI build the basic framework first, then add details incrementally. Breaking large tasks into smaller parts is a strategy you know from academic work. Third, test your results. Run the code and check whether the outcome meets your expectations. If not, describe to the agent what does not fit, and the cycle begins again. Start small, with a simple script, a small website, a data cleaning task. You have now seen what vibe coding is, how the cycle works, what it is suited for, and what to watch out for. Perhaps you are thinking, that makes sense, but is this really something for me as a humanities scholar? I am not a programmer. I come from a completely different world. I would like to address exactly this thought now, because when you look more closely, something surprising emerges. The way you work in the humanities, from research question through to critical revision, corresponds structurally almost one-to-one to what makes successful vibe coding. The abilities you have developed in your studies and research are not obstacles. They are your greatest advantage. Let us compare your scholarly workflow with the process of vibe coding, step by step. You begin with a research question. In software development, that is the problem definition. You research sources and the state of the field. Developers research technologies and interfaces. You create an outline and argumentative structure. This corresponds to architecture and workflow design. You write, analyze, edit. The AI generates code based on your prompts. You evaluate for plausibility and coherence. Developers test and validate. You correct inconsistencies. That is debugging. And you perfect through revision. That is iterative optimization. 7 steps. And at each single one there is a direct correspondence. Your scholarly workflow and the modern vibe coding workflow are structurally almost identical. So you do not need to change your approach. You only need to apply what you already do to a new tool. Let us summarize once more. Why does vibe coding suit humanities work so well? 4 core competencies come together here. First, prompting is essentially nothing more than formulating a precise research question, and that is a core competency of your discipline. Second, vibe coding is iterative work, not a one-shot result. You write a prompt, review the result, refine, review again, just like text revision or source criticism. Third, abstraction ability. Vibe coding is about describing what should come into being, not about specifying every single line of code. And fourth, semantic thinking rather than syntactic thinking. Vibe coding rewards meaning, structure, and clarity of purpose, not memorizing programming rules. Humanities scholars thus possess what can be called context-driven domain mastery, deep domain knowledge paired with the ability to articulate it precisely in language. You bring the right competencies, but how do you deploy them strategically? The key is context management. Everything stands or falls with the quality of the context you give the AI. Poor context leads to poor output. You know this. A vague research question yields vague results. 4 strategic principles help you grow beyond the basic rules. First, document your work and use version control. Save working intermediate states so you can return to them if something goes wrong, just like text versioning in academia. Second, have the agent run multiple tests. Instruct the agent to test the generated code itself before you adopt it. Third, use a second language model as a reviewer. Have another agent review the generated code, a 4 eyes principle that you know from peer review. And fourth, treat your assistant like a capable but inexperienced employee. Give clear, explicit instructions with goals and constraints. To close, one argument that may come as a surprise, especially for those who work professionally in software development. A common objection to vibe coding is you cannot trust generated code because you did not write it and do not fully understand it. But let us look at how professional developers actually work. A TypeScript developer writes code, and then a compiler automatically translates it into JavaScript. They do not systematically review this generated code. They do not audit the compiler that turns it into machine code. And the machine code itself, they certainly do not validate. They trust the compiler, the JavaScript engine, the entire tooling ecosystem. Or take Python, Whoever imports NumPy or PyTorch does not read the underlying C code, does not check memory optimizations, and is still considered a competent developer. Black box usage is the norm, not the exception. Code generated by artificial intelligence is functionally comparable to code that developers have been taking from other sources for years. Stack Overflow answers, copied GitHub snippets, automatically generated code from frameworks. The only difference is the source, not the logic. Software development always rests on chains of trust. Nobody fully verifies compilers, runtime environments, or libraries. What matters is not how code came into being, but whether you know its assumptions and can test and correct it. Sound development rests on tests, type checking, linting, and observable behavior, not on the origin of the code. And with that, the arc of this talk closes. The hurdle was never that you cannot write code. The hurdle was that computers did not understand your language. That hurdle has fallen. What counts is precise thinking, clear formulation, and critical evaluation, skills that you as humanities scholars have been training for years. The most important programming language of our time, you already speak. Let us bring everything together by placing two worlds side by side. Above you see the classic software development lifecycle. This is how software has been built for decades. Plan, design, implement, test, deploy, maintain. Each phase has its own specialists, its own handovers, its own waiting times. A complete cycle typically takes weeks to months. Below, you see the vibe coding lifecycle, and the difference is fundamental. You write a prompt in natural language. The agent generates code. You review the result, adjust the prompt, the agent revises the code, and this cycle repeats until the desired result is achieved. What previously took weeks or months can now be accomplished in days or a few weeks. No waterfall, no lengthy handovers. Instead, a fast, iterative dialogue between human and agent. Testing happens not at the end, but continuously, and you steer the entire process with natural language as the critical expert in the loop.